Hey Karamba is what you'll be saying at the end of this tutorial because we're going through Karamba today. Okay, so I'm going to show you what this workflow looks like. We're not going to build again. We're not going to build everything from scratch. Some tools are just best given to you and just used to do what they need to do. If you're interested in Karamba, please go nuts. If you want to be a structural engineer, I don't. I'm a designer, I guess, and I just want to be able to use these tools kind of quickly and at the drop of a hat. So what I'm going to do is I'm going to import. Where is it? This one. Sorry, I'm on the virtual machine as well. So apologies if it lags a little. Let's K2. And there's our lines from last time. And I'm just going to reference them in here. And we've got an analysis straight off the bat. So what Karamba does, what you need to do for your designs is break them down into linear members. So we've got like actual each, whatever you're representing, it has to be a collection or a network of lines, not curves. Lines as in the network of 2 points. The other thing about Karamba is that for any curves in the network, that all, like if you want to do an analysis, they've all going to be interconnected, right? You can't have strays at the side. And surprise, surprise, the workflows that we've been undertaking with all our topology stuff, and that horrible Voronoi thing, they've given us exactly that, like a series of lines all connected, and then we went through and got rid of all the ones that weren't connected. So you thought it was crazy, but it actually had some meaning. Cool, so let's have a look at what's going on under the hood in this definition. So essentially, you've got everything to make your model, and then it gets it gets analyzed, and then you come back and visualize the model. That's it. So just remember, I'm not a physicist. I'm not a structural engineer. Everything I'm going to be telling you, take with a grain of salt. So what you have to do is, for your model, again, make a gravity load case. Again, you can define cross sections and materials and joint conditions. That's up to you. I just want to get you going on the base model. You've got to define some supports, and then you got to have some points and elements, which is pretty easy. And again, you got to you handle your curves. Make sure you got no. This is remove duplicates. Make sure no duplicates. We've already done that, but you just want to really make sure you got no duplicates. So the first thing we're going to do is stipulate some support areas. Now you can do this however you want. The way I've done it is quickly, and computationally. So what I've done is taken all the points in my model, removed the duplicates, taken the Z measurement of them all and sorted them all according to that Z, and then I have just returned the bottom 9. Right? It's not good, it's not bad, it's just that's what's happened. Great. So then they've just gone directly into the support there. Don't worry about this. This was just another test. And then, this is like, you might need to do a bit of investigation into the support conditions that you're going to do, but then they're going to plug right into the supports. I'm going to take, these lines and make sure they're lines and flattened. And I've removed duplicates again, and this is an old version, but it still works. Lines go into line. That's fine. And they're all flattened. Cool. And then points go into points. Not into there or there. Elements go into elements. And that's basically it. Now let's look at the results. So that goes into, model comes out and we analyze it. And this is set up so it tells us that the max displacement that's happening is 41.02 centimeters or 410 millimeters. 410.2 millimeters. And there's 1 kilonewton meter of elastic energy. Long story short, that's bad. Because what will happen is it'll want to deform. Which is bad. So now we get to play a fun game of make our max displacement less than about a centimeter. So I'm gonna maybe quick fire it and see if I can get it to do that. The name of the game is minimize displacement, and just gonna unlock this for visualization purposes. If I can type it, hide, cool, and these are all going to be locked, and I'm going to play around with my points and see if I can get just with playing around, and maybe I'll change. Maybe I might actually define some supports. We'll see, and we'll go from there. But like just off that, computationally, you know, like we probably. Let's have a look. One more thing, last thing. If it's red, it's bad. If it's blue, it's good. So, you know, we're not getting heaps of displacement, but a bit. So let's have a look and see what we can do. See what we can do. Okay, guys. You can see that I did that very, very well, fairly quickly, by adding defining some supports over here. And you know, why don't we? Let me just turn that off. So what I did was, I manually came in and set some points as supports at the end of the curves. And then the lines, and then reference them in, and then what I'm about to do now is add to group, this group here. So when I go solid point on, I'll grab this one. I'm actually solid point on. Oh, what am I doing? It's points on. Points on. So when I grab this, I'll be grabbing 2 points. Like that. Oh. That's bad. So see that? I shouldn't have done that. I need to ungroup these points.
How to group? Yeah, undo that. There we go. Move. Bang. Awesome, and it works. Wow, doesn't like that, but...
Anyway, that's done. We've done pretty well, pretty quickly. And this is just me playing around with the model, right? So especially if I grab this one and go put that back onto that platform there. Oh, that hasn't done so much. Let's have a look where it wants to deform now, actually.
Still go that way a little bit. So what if I got one of these? Maybe. I did that.
3.8. I don't know, I'm going to leave it there. Gone too long. Thanks.